Now, the first question is a curve has equation y is equivalent to 2x raised to the power 3 minus 5, x raised to the power 2 minus 3 divided by 2x plus 7. X should be greater than 0. We have to find in simplest form dy over dx. So the first part, what we're going to do is we're going to write down the same equation over here so that we can see it clearly. It's very important that you guys write this down. So 2x raised to the power 3 minus 5x squared minus 3 divided by 2x plus 7. So now what I would like you guys to do is to simplify this equation. Let's say write all the x's in terms of their powers. So you're going to write y is equivalent to 2x cubed minus 5x squared minus 3 by 2 x raised to the power negative 1. Since we know x is at the bottom, we have to make it on the top, plus 7. Now this is a nice way of writing it down as first. So after this, we have to do dy over dx. That's the first important part. Do check out the video on differentiation. I think, yeah, I made a video on that. So to differentiate it, we're going to do 2 brackets 3x raised to the power 3 minus 1. I'm just going to show you the steps so that you guys know how to do it. Minus 5 brackets 2x raised to the power 2 minus 1 minus 3 by 2 negative 1 x raised to the power negative 1 negative 1. You're going to subtract that. Since this is a constant, you're just going to leave it as 0. Now we have to simplify this, so it's going to become dy over dx. That's going to be equivalent to 2 over 6, 6x raised to the power of 2 minus 10x raised to the power of 1. So you're just going to leave it negative 3 by 2 times negative 1. That's going to become a positive 3 by 2. X raised to the power negative 1 minus negative 1 is going to become x raised to the power negative 2. Now we can simplify this back, so we can write dy over dx is equivalent to 6x squared minus 10x plus 3 divided by 2x raised to the power 2. We just put this x raised to the power negative 2 at the bottom so that we have a nice simplified expression. Alright, so this seems good amount of working. Let's move on to the next question. Now the next question is talking about point P lies on the curve and has x coordinate half. So what we're going to do is we're going to write the x coordinate. We know it's half, and we have to find an equation of the normal to the curve at P, giving your answer in the form of ax plus by plus c is equivalent to 0, where a, b, and c are integers to be found. So the first thing I would like you guys to do is to remember that a nice little formula that we can use here is that a gradient, let's say the gradient of a normal is equivalent to negative 1 divided by the gradient of a tangent. So what I mean by that is we're going to use our dy over dx expression from A, and what we're going to do, we're going to substitute the value of x into that equation. So you're going to write dy over dx. Now the reason why we're substituting the value of x into this equation is because we're trying to find out the gradient of the tangent, so that we can indirectly find out the gradient of the normal, which we can use to find out the equation of the normal itself. So dy over dx is going to be equivalent to 6 brackets half. That's the value of x, which is substituted as into x squared minus 10 brackets half plus 3 divided by 2 brackets half x squared. Now, if you put this in a calculator, by the way, do use a calculator for the exam, you're going to get 5 by 2. This is going to be our dy over dx. We know that the gradient of the tangent is not 5 by 2, but it is the gradient of the curve. Indirectly, the gradient of the tangent to that curve. So we know the gradient of the curve is 5 by 2. Now, what you need to do is find out the gradient of the normal. So to find out the gradient of the normal, what we're going to do, the reason why we're finding out the gradient of the normal is because the question is asking us to find out the equation of the normal to the curve at that point. So what we're going to do is to find out the gradient of the normal, you just do negative 1 divided by 5 by 2. Indirectly, you're going to get a negative 2 by 5. Now this is going to be your gradient of the normal. So now we know the gradient. Now all we need to do is write it in terms of y equals mx plus c. That's the notation we're supposed to be using in the equation. So I'm just going to write it down here. Y is equivalent to mx plus c. So we know that y is equivalent to negative 2 divided by 5x plus c, since we have found out the gradient of the normal. Now we have to find out what point C is all about. So when you substitute the value of x into the differentiated equation, you're actually getting the gradient. Now, when you substitute the value of x into the equation at the top, you're most likely to get the coordinates of y. So that's the reason why we're going to substitute now the value of x into the top equation. So the top equation is y is equivalent to 2x raised to the power 3 minus 5x raised to the power 2 minus 3 divided by 2x plus 7. This is the equation at the top. That's the current equation that we're given here as well in the question. And we're going to substitute the value of x given by the question itself to find out the value of y. So when you substitute that, it's going to come y is equivalent to 2 brackets half cubed minus 5 brackets half square minus 3 divided by 2 half plus 7. By the way, do show all your working. It's very important that you guys show the working. So you're going to get y's value as 3. So we know the coordinates indirectly is that when x is equivalent to half, we know y is going to become 3. You can write it down in terms of coordinates, half comma 3. Alright, so now once you do that, we know the coordinates of x and y. We have to find out what c is. We can substitute the value of x and y into this equation. Indirectly, I'm just going to rearrange this as minus 2x plus c is equivalent to y, negative 2 by 5 brackets half. So indirectly, we're finding out the value of c. So equivalent to 3. Now, when you rearrange all of this, you're most probably to get c's as 16 divided by 5. This is going to be the value of c. All we need to do is now just substitute this into the equation back, which you're going to get y is equivalent to 2 minus 2 divided by 5, x plus 16 divided by 5. And now this is going to be your equation. This is not where we're going to leave it. We have to rearrange it in terms of, let me just reload this system again. So we're going to rearrange it in terms of ax plus by plus c. We have to rearrange the equation in that form. So when you rearrange it, x plus by plus c is equivalent to 0. We are going to rearrange it as minus 2 by 5x minus y, actually, plus 16 by 5 is equivalent to 0. Now, we cannot leave it as it is currently as well, because we have to multiply some of these values by 5. Now, the reason why we're multiplying this whole equation by 5 is because we have to make this where a, b, and c are integers to be found. So that's why we're multiplying this, let's say, by 5. In this case, we know y's value to be roughly, if you look at it, you're just going to rearrange this, right? So we have to rearrange this carefully so that we get this right. So we're just going to multiply everything by -1 first so that we get it in nice positive integers. So -16 by 5. Now we can multiply everything by 5. So you're going to get 2x, okay, plus 5y minus 16 is equivalent to 0. Now this is a better notation. The reason why I multiplied it by -1 at first because I just wanted to get rid of the negative sign. And we have to make this into whole numbers, so we get 2x plus 5y minus 16. We know a is 2, b is 5, c is -16. You can just write it down, it's just your choice, but this is going to be your final answer for that question. Alright.